Welcome protein coders, let's build some coding muscles. Today we're gonna study topological sort. In topological sorting, the node which comes first will be written first. Okay, so let's see in the graph 1, you can see 0 comes first, then from 0 we went to 1, then we went to 2, right? So our topological sort order will be 0, 1 and 2. From here you can see to say one node comes before second node, we need a directed edge, right? So we can't say the same thing into an undirected graph. So we got an observation from here. We can have topological sorted order only in directed graphs. Okay. Now let's see into the graph 2. We can have topological sort as 0 because 0 comes first, then 1 or 2, or you can say 0, 2, 1 because 1 and 2 are at similar depth from 0. Okay, so from here we also got an observation that we can have multiple topo sort orders in a graph. Okay, now let's look in the graph 3. We have a cycle, right? So let's start from 0. 0 came first, then came 1, but 1, because we have a below edge, so 1 comes before 0, so it's a contradiction, right? 0 comes first before 1 and 1 comes before 0, so it's wrong. Let's see it in graph 4. Let's start from 0. We can have 0, 1 and then 2, and then 2 comes before 0, so again we are going into a cycle, right? So from here we can have our final conclusion that graphs should be acyclic. So in topological sorting, we have 3 major observations. We can only have topological sort in directed graphs which are acyclic, and we can have multiple topo sorts. The basic definition is the node which comes first will be written first. Now let's see how we gonna find our topo sort algorithmically. Let's just first write the topo sort of this graph. 0 comes first, so we will write 0, then 1, then 2 and 3 can be interchangeably written, and then 4. Okay, in this video we're gonna find topo sort using DFS and with the help of a stack. You will see why we need a stack. Let's perform DFS first. From 0 we will go to 1, then 1 we will go to 2, from 2 we can go to 4. At 4 our DFS ends. Okay, and while returning we will push the element into the stack, okay, and trace back. So from 4 we will put 4 into the stack and then move back to 2. 2 doesn't have any unvisited neighbor, so from 2 also we will trace back and push 2 into the stack. 1 has 3 as unvisited neighbor, but 3 doesn't have any unvisited neighbor, so from 3 again our DFS call will trace back and we push 3 into the stack. Now 1 doesn't have any unvisited neighbor, so our DFS will again come back. So we'll push 1 into the stack and come back to 0, and finally we will push 0 into the stack. So if you look carefully, what we've done is while returning from the DFS, we are pushing the elements into the stack. And if you look closely into the stack, if you pop out every element in the stack and get it in a vector, you will get 0, 1, 3, 2, 4. And voila, this is our topo sort. Congratulations. Now you will ask me why we are doing this, right? Why we are pushing element while returning back from the stack, right? So I want you to have a note here. That we are processing the nodes while returning back, which is nothing but a post order traversal, right? In post order, let's see in the graph, let's say we have a node and it has some children nodes. Then what I mean to say post order traversal is that before processing this node, I have visited all of its children's before it, right? That is what we do in post order. We visit the children's first, then we come to the parent. So we have visited all the children's before it, right? And then we have pushed this element into the stack. And this is what our topo sort is, right? Every children of the node is already present in the stack. Then only we will push this element into the stack, right? So now let's see in the code how we're going to do it. We will perform simple DFS. we will mark a node as visited first, then we will traverse for neighboring nodes using adjacency list. If the neighboring node is not visited, we will simply call DFS. And at the end, while we are returning back, remember, doing post order operation or processing, we will simply push the node into the stack. And that's it. And at the end, you can just call this function and get the node into a vector and return it. So let's see what we have studied today. In topological sorting, we studied topo sort is nothing but the node which comes first will be written first, right? We have 3 observations. We can have topo sorts only in directed acyclic graphs, and we can have multiple topo sorts. Then we used a stack and DFS to do a post order traversal processing, that we have pushed all the children nodes first in the stack, then the current node. And this is what topo sort is, that all the children nodes will come later with respect to the current node, right? Then we saw the code for the topo sort, right? We will simply perform DFS, and at the end, while returning back, we will push the node into the stack, right? So that's all from my side, guys. Thank you for listening. If you have any questions, please comment down. If you don't understand, don't like, don't subscribe. But if you do, please show some support. Keep smiling, keep practicing. Thank you.